we'll start our discussion about the Reimer-Tiemann reactions. Phenol undergo Reimer-Tiemann reactions in presence of chloroform and KOH undergo on heating. It will form salicylaldehyde. We are getting the mixture of salicylaldehyde. One is orthosalicylaldehyde and other one is the parasalicylaldehyde. Okay, so here orthosalicylaldehyde is the major product. This is more stabilized due to the resonance. So let's see the very interesting mechanism of this Reimer-Tiemann reactions. Okay, so we know the intermediate in this Reimer-Tiemann reaction is dichlorocarbons. Let's start the procedure. Step 1. Here chloroform is used. So in the presence of base OH minus, this hydrogen is abstracted and it becomes CCl minus and H2. Now this chlorine group is removing and it's become CCl lone pair. This is called dichlorocarbon. Now the question is, why this dichlorocarbon is singlet or triplet? This carbon is where singlet or triplet. This is the singlet carbon, most important. This dichlorocarbon is the singlet carbon. Why it is singlet carbon? In the last part of our example, by doing some reaction we can prove this is the singlet carbon. Okay, singlet. Suppose here this one orbital is vacant and one orbital is occupied. Lone pair is present in one orbitals. Okay, so this is the singlet carbons. Now what happens in step 2? Now this is our phenol molecule. In the presence of base, it will abstract this hydrogen and it will form phenoxide ion. This phenoxide ion is more stable than the phenol that previously you have studied. Phenoxide ion is more stable than the phenol. If we draw the resonating structure both for the phenoxide ion and phenol molecule, we can have a very easy comparisons that the resonating structure in phenoxide is more stabilized than the phenols. So we'll not go details about this case in this case. So now it's from the phenoxide ion. Now this phenoxide ion now react with the dichlorocarbon. This is the sextet molecules. In outermost stress 1 2 3 4 5 6 electrons are present. That means electron deficient. That means its act is the electrophile. It needs electron. So what will happen? If we will draw the resonating structure, it will form like that. Okay, so our molecule will be formed. We have to write here lone pair is present, so due to this negative charge formed here. Now this negative charge will be abstracted the proton, and it will form like that. So the structure will be now again this OH minus will attack here 2 times, and the structure formed will be water molecule will be removed. Now it will undergo hydrolysis. On workup, it will form phenol orthosalicylaldehyde. So in this reaction, what we see, dichlorocarbene is the intermediate in this reaction. Formation of the dichlorocarbene is the gist driving force towards the destiny of these reactions. Without the formation of the dichlorocarbene, this reaction could not be possible. And one important thing here, we have to remember, this dichlorocarbene is the singlet intermediate here. Okay, so in the next class we will carry forward the discussion little bit more.